Good morning, students. Today we start with chapter number 5, that is acids, bases and salts. In today's lecture, you will be mainly studying about what are acids, bases and salts. Next, you will be studying about what do you understand by dissociation of ionic compounds. We will also study about Arrhenius theory of acids and bases. And lastly, we will go to the topic of classification of acids and bases. Now, what are acids? Acids are those which are sour in taste. Acids have H plus ion concentration in them. Acids turn blue litmus red. Example of few acids here are H2SO4, HCl, HNO3, etc. What are bases? Bases are bitter in taste. They have OH minus concentration present in them and they turn red litmus blue. Some examples which are mentioned here are NaOH, that is sodium hydroxide, KOH, that is potassium hydroxide. Okay, you can see here differences between acids and bases. Taste is sour, taste is bitter. React with some other metals to give hydrogen gas, and when we touch bases, they are slippery in touch. Then acids conduct electricity in solution, that means it helps in the passage of electricity, and on the other side bases, they dissolve the fats and oils. And down here children, it is the pH scale. The pH value which is ranging from 1 to 6, it is acidic in nature. pH 7 is neutral, and from 8 to 14, the solutions which fall under that category are basic solutions. What are salts? Those ionic compounds which have basic radical other than H plus and an acidic radical other than OH minus are called salts. Example, ammonium sulfate. Some of the examples of salts are shown here, like zinc sulfate, ZnSO4, K2Cr2O7, that is potassium dichromate, CuSO4, that is copper sulfate, CaSO4, that is calcium sulfate. So some of the examples are shown here of various salts. Now the next topic here is formation of NaCl compound children. Schematic diagram is shown here. About the same topic we had studied in the last chapter too. So I am not going into detail. It is the same thing to be repeated. Going to the next topic, dissociation of ionic compound. To dissociate means to break up, to segregate, to separate. Okay. So on dissolving in water, an ionic compound like NaOH is a ionic compound, forms an aqueous solution. Aqueous means the solution is formed in water. In the solid state, the oppositely charged ions in the ionic compound are placed side by side. When an ionic compound begins to dissolve in water, the water molecules push themselves in between the ions of the compound and separate them from each other. That is, an ionic compound dissociates while forming an aqueous solution. Okay, you can see here dissociation taking place. In sodium chloride, NaCl gets broken into Na plus and Cl minus ions in the aqueous medium. AQ over there is aqua, aqueous solution. AgNO3, that is silver nitrate, also getting broken as Ag plus NO3 minus. Again, AQ over there is in aqueous solution. So these kind of reactions are known as dissociation reactions. The next topic, Arrhenius theory of acids and bases. How Arrhenius defined acids and bases. According to Arrhenius, an acid is a substance which on dissolving in water gives rise to H plus ion as the only cation, that is a positive ion. For example, HCl, H2CO3. Now HCl is broken as H plus, aqua plus Cl minus, aqueous. And bases is defined as, a base is a substance which on dissolving in water gives rise to OH minus ion as the only anion. that is a negative radical. For example, NaOH. When it is broken, when it is dissociated, we get Na plus in aqua medium and OH minus again in the aqua medium. Okay. Classification of acids and bases. Strong acids. Now what are strong acids? On dissolving in water, a strong acid dissociates almost completely and the resulting aqueous solution contains mainly H plus ions and the concerned acidic radical. For example, HCl, HNO3, these are the strong acids. Weak acid, what is the difference we will see? On dissolving in water, a weak acid does not dissociate completely and the resulting aqueous solution contains H plus and the concerned acidic radical in small proportion along with large proportion of the undissociated molecules of the acid. For example, H2CO3, that is carbonic acid. Strong base. On dissolving in water, a strong base dissociates almost completely and the resulting aqueous solution contains mainly OH minus ions and the concerned basic radicals. For example, NaOH. And what is a weak base? On dissolving in water, a weak base does not dissociate completely and the resulting aqueous solution contains a small proportion of OH minus ions and the concerned basic radicals along with the large proportion of undissociated molecules of the base. For example, NH4OH, that is ammonium hydroxide. Okay, now what is an alkali? The bases which are highly soluble in water are called alkalis. For example, NaOH. And the last topic, what is basicity and acidity? Basicity of acids, the number of H plus ions obtainable by the dissociation of one molecule of an acid is its basicity, and the number of OH minus ions obtainable by the dissociation of one molecule of a base is called its acidity. So we end today's topic here, children. We'll be continuing with the next topic next time. Thank you.